we're going to see how we actually um, do a simple model in using CAMG. CAMG stands for Computer Aided Modeling Program, and the G for Graphical Interface with or graphical input. So I have on the screen a very simple example and the corresponding bone graph of this example. So let's see how we do with the software. Okay, the first thing that we have to realize is that we have a physical system in here that has a force in here, has a applied force to the right of this right here. We have defined the motion positive to the right, and so the spring is an extension here. This is the spring K, this is the damper B. So this corresponds to that. The I element is represented by this symbol, or the mass rather, represented by symbol I for inertia. The C element is representing the spring as a compliance element. And this is a resistive element which is represented by this R. So you see, joined together as a common to all these participants in the system, you may say, is this one junction which indicates that the velocity is the same for all these elements that are connected together. So that's why it makes this a nice simple system. So what our objective would be, we're gonna do the steps here, and I would say the first step in the process is that we draw a bone graph model that represents the physical system. Okay, very good. We have done that. The next thing we're going to do is to enter the bone graph into CAMG. Okay, and so let's go do that. We're gonna go over here and we're going to call it from where it is installed. On the list here is CAMG. We click on the icon and we open this up, and in here we have this. We are going to open it up and open a new model here. So let's begin building this model here. I'm having the I think it would be a good idea always to have the model itself to be able to do it and have it available for us on the screen. So let's give it let's make an effort to do that, and that is over here. And so I am going to minimize this a little bit so that we can have both of them on the screen. See, it's actually a good idea to have that. So what I would do is put this element first, you know, the SC element right here, put it on the screen. Then we have the one right here, and then we join the you know, with the bone graph model. Then we have the I element over here, which is over here. And then you have the C, which is, and then we put the R element in the end. Okay. So here we go. So we have we have entered this little system in here. Okay. And we have now the all the elements with the bonds, and you notice the computer, as you build it, also did the causal marks for you, so you don't have to do that. The only thing you have to be careful is those arrows from which element to which element power flows. But what I want to say is, once you are here, it's important to explore this. And I am going to use a couple of options here which are really nice. This is the peak. If you do a peeking here with this eye, you can see the equations behind it, because it's very obvious that this is it's not just a picture. It's actually a model that contains all those equations. And you're beginning to see here, you say, interesting. If I have all these equations, the computer has already derived them for me. And that's exactly what has happened. The moment you assemble this, CAMG is smart enough not only to know the equations of each element you put in there, but to assemble those as you went along. By the time it's over here, everything is already assembled. It's almost as if you totally connect it, if the equivalent of having done the entire block diagram, having derived the equations and having done the block diagram. Because you see here, there's another option which is interesting to look at. You click on this, again on the picking menu here, and see what happens. Each element and the corresponding block diagram is what's behind these symbols. See, the junction in here has the summations of the efforts, and this is the source in here. So you see all this has been, whether it is in the block diagram form, or it is, which is the Simulink notation, or it is in the equations form, all of this is contained in this little picture. So what we're going to do is go from this model, which I already showed you that there is a, is contained here. It has this information. We're going to go in an automated way, go directly to the MATLAB and Simulink. So what we're going to do is we'll say, okay, well, before I do that, there's other options in here that you can analyze. And for example, if you click explain, it has a little stethoscope. In this, it doesn't do very much, because we have a situation where we don't have a complicated system. We don't have a complicated bone graft model. However, if we click over here anywhere, it has a message that you can see. It says, let me move it up a little further, because you are not seeing that. Um, yeah, see, there it is. It says new element. Do you see it on the bottom? It says new element. There's no problem, it says. So, but if there would be something red on the screen, this would help you detect what the problem is. So, okay, so what we're going to do is we have entered the bone graft here. Then we so make sure there's no red elements on the let's put it here. Make sure no red elements are displayed. If they're red, it means that if red means otherwise, I will say correct any inconsistent connections, or you can say causal problems, you know. We don't have any of those here. So once you do this, we go to the interface, which is what the other thing we should do, is we should go to say interface to MATLAB. Okay, and then the computer is gonna come with a little messaging here that say CAMG MATLAB models. You have this, it will generate this four files in here. And we're going to examine exactly what those are. So in here, I would say step number 4 basically is you would say pick MATLAB interface, all right? And then on the first step would be use the M files for the simulation. Okay, so what has happened is MATLAB came back in here and gives us these files in here. The CAMG and MATLAB interface interacted together and produced these 4 files: the CAMG mod, CAMG equations, CAMG sim, and CAMG num. Very briefly, there's an explanation at the beginning of each one of those files, and particularly on this one in here, on this file in the CAMG mod. This stands for CAMG model. Model data means CAMG equations file, CAMG symbolic file, and CAMG numeric file. For the time domain simulation, which is what we would see first, we are going to worry about only these 2. For the frequency domain and other uses, also using a state space form, we'll use these other 2 files. So for now, let's look at this and see what we have in there. That is what we need to do. So in here, what we have is as follows. Let's start with the CAMG mod. In here, CAMG mod allows us to put the initial conditions. It created these variables based on the bond numbers. The Q variables for the initial conditions, it means the Q is a displacement initial of the spring, and this would be the momentum of the mass. I say those are 0. And then you have the in here the values of the I2 is the inertia. Let's just make this a 2. We're just putting some numbers to get a simple plot without relating really to any major physical system, but really just a small one that would give us a simple simulation. And this maybe put it as a 3 over here. This is the input in here. I'm just gonna give it a step unit input in here just to test the system. And we're gonna say do the simulation from 0, and t final is to 5 seconds here, like that. And that's about it. On this file, what you have is not only the initialization of the variables, but also you have already some commands that allow the simulation to command MATLAB to give you these plots. In fact, it's going to display the first state variable and the second state variable. And it gives you a list of what they are in this case. See, those are the 2 state variables that you have. And so if you go here to run, well, one thing, the equations of the system are contained here. We'll examine in more detail what these equations are, how this file is structured, but these are the derivatives. What is important for now is to see if we can get this going. So you click it on run up here, and lo and behold, the computer did your simulation right here. So it gave you two plots for that step input, and you got the results of the simulation. Did we derive any equations ourselves? No. Did we have to do a block diagram ourselves? No. Everything became an automated process in such a way that what we're doing is basically controlling the model that CAMG produced, the model that is now a MATLAB M file, which MATLAB understands. So in a nutshell, this is how you perform a simulation. You do all those steps. I think if we complete our notes over here, I would say use the files for simulation, and then you could say number 6. You could say use the plots or numerical data to make decisions about the system. And that would be it. So this is how you do it. This is our model here. These are the steps, and these are the results as you see from the simulation already in MATLAB. I think in here we have all those plots on both of those.